Good afternoon.
Good morning, everybody, and welcome to our webinar on slot sensors, MD portfolio. Before starting, let me briefly introduce myself. I'm Giovanni Principe, product manager in MD Microdetectors, and today I'm going to lead you during this interesting lecture. Here, a colleague of mine, Fabrizio Marchi, is going to support me during this webinar by trying to answer to your questions. So if you have any doubts, any curiosities, if something is not so clear, do not hesitate to write down your questions, addressing them to our Q&A profile. And Fabrizio will be very happy to support you. Right, Fabrizio?
Yes, of course.
Okay, thank you very much. Okay, I think that we are ready to start. So, what we are going to talk about today. First of all, we are going to discuss about the slot technology. So the technology on the basis of the forks, on the basis of slot sensors. And in particular, we are going to show you two different technologies. On the one side, the photoelectrical technology, the photoelectrical product, and on the other side, the ultrasonic slot sensors. Then a brief picture of the MD slot portfolio will be shown, and we can follow with all different slot series like FC5R, FC6I, FC6L, FC7I, FC8U series. Then we can talk about a little bit of some interesting applications that we already solved thanks to the usage of our products. And finally, we can, let's say, have a touch with the slot technology during the practical part of this lecture, where we want to show you how to adjust a slot sensor. In particular, we are going to consider the FC8U model, because in this case, what we are going to learn can be applied also for the FC7I models. Okay, so let's start with a brief discussion about this slot technology. First of all, what about a slot sensor? How can we define this kind of product? We can define a slot sensor as a through beam sensor, including within the same housing, within the same body, within the same elements, both the emitter and the receiver. And thanks to this mechanical configuration, these two elements are already aligned, so we can overcome all the initial issues related to the, let's say, installation of a through beam systems with different elements. And also on the basis of this fact, of this unique mechanical, let's say, location of the two elements within the same housing, we have the maximum alignment and focalization in terms of light beam, a high accuracy, and furthermore, we have no problems in terms of, let's say, incorrect alignment caused by vibrations. As I said before, we can make a distinction within our portfolio between photoelectrical slot sensors and ultrasonic ones. In particular, the photoelectrical slot sensors are based on red emission or infrared emission or laser red emission for high precision applications or for the detection of transparent objects. So we can say that these photoelectrical sensors can be used to detect objects in general or opaque labels. On the other side, we have slot sensors based on the ultrasonic emission. And this ultrasonic emission allows us to overcome the problems related to the transparent labels. So with the ultrasonic sensor of our FC8U series, we can detect the transparent labels. Now, in this slide, we can observe, we can have a clear picture of the entire slot sensor portfolio. And in particular, you can observe that here we have two dimensions, two axes. On the one side, the performances level, here, basic or advanced. On the other side, the applications difficulties. And you can observe how the first series, the FC5R, can be used for basic, let's say, applications. So applications with a low level in terms of difficulty and with basic performances. Then the level of performances increases when skipping to the infrared emission, like for the case of FC6 and FC7 series. Of course, when using the laser, the red laser emission, we have high precision, as we are going to see with some of our applications. And finally, the ultrasonic emission makes it possible to detect also transparent labels. Okay, now we can start by exploring different series, different models for the detection of objects. Let's start in particular with the FC5R series, which can be defined as a plug and play, let's say, series, because these models do not need any kind of adjustment. They are based on high power red LED emission with a high switching frequency. In fact, you can observe here 4000 Hertz, and they are able to detect very small objects in the order of 0.8 millimeters and 1.2 millimeters. Here, I want to underline the fact that we can offer a lot of different items, 24 items of the same series. Why? Because we have different combinations, different, let's say, different combinations in terms of mechanical dimensions, mechanical sizes. So in terms of depth and width. In fact, these sensors have a depth included between 40 millimeters and 124 millimeters. On the other side, in terms of width, they are included between 30 millimeters and 180 millimeters. In terms of output, we have PNP or NPN models, dark on or light on. So we have all the models for satisfying all of your necessities. Now we can explore the FC6I series. Here we have the adjustment the power adjustment by buttons, and the emission is infrared and not red, with metal housing and with a very high switching frequency equal to 10,000 hertz. Within this series, we have an electrical connection based on M8 connector of 4 pins, while within the previous series, we had just M8 connector with 3 pins. So pay attention to this different electrical configuration. Also in this case, we have a different output, so different logics, NPN or PNP selectable via cable, light on, dark on, and we can switch from one to another through a selection by button. And we have the ability of this sensor to detect very, very, very small objects, in this case with a size of 0.2 millimeters. Here, also in this case, we have the possibility of combine together different depth and different width, depth going from 40 millimeters to 95 millimeters, width going to from 2 millimeters to 120 millimeters, with a total number of items equal to 18. But here I want to underline the fact that within the FC6 series, we have this special mechanical configuration with a width of just 2 millimeters or 5 millimeters. They are very effective when we want to detect, let's say, the passage of labels. So we can use models belonging to this series also for labels detection, even if we have 2 series devoted to this kind of application, as we are going to see later on. Now we can, let's say, talk about this series, the FC6L series, with laser red emission, and the possibility also in this case of adjusting the power, the emission power, through the plus and minus buttons. Also in this case, we have the metal housing with a switching frequency equal to 10,000 hertz. Also in this case, NPN or PNP selectable via cable, light on, dark on, selectable by switching, let's say, through the button. And in this case, due to the application of laser emission, we are able to detect the passage of very, very, very small objects. And we are going to explore an interesting application within the pharma industry, where, let's say, this ability of these models is quite useful. We are able to detect in particular objects of 0.05 millimeters. In terms of mechanical size, mechanical configuration, different, let's say, different model are available in terms of depth, from the 40 millimeters to 95 millimeters, in terms of width from 2 millimeters to 120 millimeters, for a total number of items equal to 18. We can start now exploring these models devoted to, let's say, this special kind of applications, the detection of labels. In particular, we can start with the FC7I series, based on the infrared emission with the possibility of teaching, with the possibility of adjusting the power emission, both in remote mode, so via cable, and by using the two buttons, the plus and minus, that you can observe here on the top face of the sensor housing. In particular, these models are able to detect very small labels with a label size equal to 2 millimeters and a gap between two consecutive labels equal to 2 millimeters. This kind of models, due to the particular emission, are able to detect the opaque labels. From a, let's say, mechanical point of view, the housing is based on plastic material, which are the, let's say, the output that we can grant with this series. We can select by button the light on, dark on output with models granting both the PNP or NPN logic with a very high switching frequency, 10,000 Hertz. Mechanically, this slot sensor has a, let's say, fixed size with a depth equal to 40 millimeters and a width equal to 3 millimeters for a total number of items equal to 3. Here we can explore the FC8U series with ultrasonic emission. Also in this case, we are able to adjust, to teach the sensor, so adjusting the power emission, both with the possibility of adjusting it in remote mode via cable, or through these two buttons, the plus and minus. And we are going to see how to do it during the practical part of our lecture. Also in this case, the slot sensor is able to detect very small label with a size equal to 2 millimeters and a very narrow space between two consecutive labels equal also to 2 millimeters. In this case, we can use this sensor in order to detect the passage of transparent labels where the FC7 high series could have some issues, let's say. In this case, the housing is metallic. In terms of electrical outputs, we have light on, dark on output selectable by button, and PNP or NPN models with a switching frequency equal to 1500 Hertz. The mechanical configuration is based on a depth equal to 70 millimeters and a width equal to 3 millimeters for a total number of items equal to 3. Okay, now we can, let's say, talk about some interesting applications that we already solved thanks to the usage, thanks to the installation of our slot sensors. In particular, we can start with this application into the food industry. We are considering here this bottling plant where during a quality test, a quality check, we want to verify, we want to test if the cap on the top part of the bottle has been inserted correctly or not, and how to do it thanks to the application of a slot sensor, in this case of an FC5R or FC6I or L model, which can verify the correct let's say, alignment of the cap. If the cap has not been inserted in the correct way, the bottle can be extracted by from the conveyor, the production line, in order to be reworked apart. So in order to let's say to solve this quality issue. Another interesting application is here within the glass industry. In particular, in these plants, we want to verify, we want to detect the correct positioning and alignment of a glass panel. And in this case, we have used an FC6L slot sensor. And this is an important test of the fact that thanks to the laser emission, we are able also to, let's say, to work with transparent objects like the glass. Also, thanks to the laser emission, we can reach a very high accuracy, a very high precision, and we can detect very small objects. In particular, let's say, going into the pharma industry, we can use this slot sensor, the FC6L model, in order to understand if needles have been installed on the top of these syringes. And also in this case, we can check the production quality of these, let's say, important goods in the pharma and in the pharma field. We can, let's say, come back to the food field, to the food industry, with the analysis of this conveyor of this plant, where these small sweeties are transported. In particular, we want to count to detect the passage of these small sweeties, and we can, let's say, identify them at the end of the line, in this case, thanks to the application of an FC6I or FC6L slot sensors, which are able to detect small objects, but also to work with very high speed. In fact, you can imagine how much of these small, let's say, sweeties can be transported, let's say, per each second, thanks to this conveyor. So we need a sensor, a very fast sensor. Here, thanks to the installation, thanks to the usage of the FC7i slot sensors, we can detect the passage of opaque, let's say, labels with a very high speed, with a very high switching frequency equal to 10,000 Hertz. And with very small size, very small dimensions of the labels themselves, 2 millimeters. While if we consider transparent labels, as I said before, we can skip for similar applications to the FC8U models. And still remaining on these FC8 models, we can show you how to adjust a slot sensor, as you can observe in this picture, through the FC8U model. But the procedure that we are going to show you, thanks to the support of Fabrizio, is, let's say, applicable also to the FC7i series. Okay, so now we can we can start with this practical part. As you can observe, Fabrizio is now introducing between the emitter and the receiver of the fork of the slot sensor, is introducing this belt, this labels belt. And you can observe they are transparent. Now we are going to show you how to adjust the sensor through the buttons. How to enter the adjustment mode, simply by pushing together the plus and minus buttons. The red LED starts blinking, and then you have to move towards right and left, as Fabrizio is showing you, the belt. Then, when you have finished the adjustment procedure, you can push the minus button, and then the slot sensor is ready to run, ready to perform, as you can observe. Of course, the identification of the, let's say, the age of a single label is shown through the yellow LED. Now we can show you how to adjust this sensor in remote mode, so via cable. In particular, you have to use the white wire and connect it to the positive pole, as Fabrizio is doing now. Then you can observe the red LED blinking. You have to move also the belt, and now the sensor has acquired correctly, let's say, the sides of labels, and it's able to detect the passage of this transparent label on the belt. Okay, thank you, Fabrizio, for this practical demonstration. And now we can, let's say, come back to the presentation in order to have a brief recap of what we have learned during this lecture. First of all, we have discussed about the slot technology with a distinction between photoelectrical and ultrasonic models. Then we have had a picture of our slot sensors portfolio, followed by an analysis of different series within the portfolio itself: FC5R, FC6I, FC6L, FC7I, FC8U series, with all of their technical features and the, let's say, the strength points. Then we have seen some interesting applications that we solved thanks to the usage of our sensors. And finally, we have just seen how easy it is to adjust our FC8U or FC7I sensors. Okay, unfortunately, we just reached the end of this lecture, but of course there are a lot of other stuff to say, to learn about these slot sensors. So if you are interested, if you have curiosities, doubts, or if you want to provide us with your feedback, do not hesitate to write us at microdetectors, at microdetectors.com, and please visit our website to discover what's new, microdetectors.com. And I also, let's say, invite you to subscribe to our YouTube channel and to follow us on LinkedIn, in order to be always updated in terms of our news. Okay, now we have finished. Thank you for following this lecture, and see you soon at the next webinar. Bye bye.